Okay, let's finish page 3 and 4 of section 3.6, marginals and differentials. All right, so we did use cost, revenue, and profit function before in some of these previous business application examples, but when we say marginal cost, marginal revenue, and marginal profit, they just refer to the approximate cost or revenue or profit of the x plus first item. Simply, we're just going to take the derivative of the cost function, revenue function, and the profit function, and we can plug in the x value we want. But I also like what they have here. If you take a look, they wrote that the marginal cost is approximately the cost of x plus 1 unit minus the cost of x unit. And if you add c of x to both sides, you can solve for the c of x plus 1. I think we'll use both of these in the next 3 examples that I prepared for you. The first one, example 4, is from the textbook. So I think I'm gonna, instead of typing in numbers when we plug in evaluating these functions, I'll probably use the numbers from the textbook. But example 5 and 6 are similar to what you will see on your homework. Just wanted to grab at least 2 out of about 8 that you're gonna try for me this weekend, and kind of go over the similar ones. All right, let's see. All right, let's get started. So given that we have a cost function, c of x is 62x squared plus 27,500. So imagine if x is 0, the cost will be 27,500. And what else did they give us? Just kind of thinking about these. The revenue function is this. Here's the revenue. So we have the cost function and the revenue function. One thing that we're missing is the cost of profit function. And of course, they're asking you to find the cost function first. So remember, profit is simply, let's write that down. Profit is simply revenue minus, so we're going to do r of x minus the cost. So they didn't give us a profit function, but we can find out what p of t is, p of x is. We're going to subtract r of x, which is x cubed, minus 12x squared, plus 40x, plus 10. And then let's subtract 62x squared, plus $27,500. If you subtract these two, we'll get the profit function. All right, what's that going to be? Let's try to write this in standard form. I'll have x cubed, right? But this, and I have to combine this negative 62x squared. So if you do negative 12 plus negative 62, you will get negative 74x squared. Plus 40x doesn't have any like term. Let me write it. But then I have my 10 minus 27,500, right? So that will give us negative 27,490. So here is our profit function, P of t. So if you take the derivative of this, we will call that the marginal profit. We'll use that in, I think, part C. All right, B is simply asking you to find the total cost, revenue, and profit from the production and sale of 50 units. So X is 50. X is 50, and simply they want you to plug in that 50 into the cost function, revenue function, and the profit function. So let's first do the cost. What's the cost of producing 50 items and selling 50 items? That's going to be 62 times 5, 50 squared, plus $27,500. How much will it cost? That's going to cost them $182,500 to produce and sell the first 50 units. All right, what about the revenue? Let's plug in that 50 into the revenue function. This one right there. That will be 50 squared. I'm sorry, 50 cubed. Minus 12 times 50 squared. Plus 40 times 50. Plus 10. And if you evaluate that, you will get approximately $97,010. The total cost, the total revenue from the sale of the first 50 units is that much. Now let's do the profit. Profit at 50. I can plug in 50 into this profit function if I want, but I also know that profit at 50 is equal to the revenue at 50 minus the cost at 50. Revenue minus the cost. That's going to be our two answers that we just found above subtracted. $97,010 minus $182,500. Oh, they're going to have a negative profit. And if you subtract them, you will get negative $85,490. What does that mean? There is a loss of $85,490 when 50 units are produced and sold. So what should they do? They shouldn't produce and sell 50 units. They should probably sell and produce more than 50. So the next question to think about is, how about the marginal cost, marginal revenue, and marginal profit when 50 units are sold? So these are the derivatives, right? The marginal cost. Let's do that first. Marginal cost. You have to take the derivative of C of x. So look at this function. C of x is 62x squared plus 27,500. If you take the derivative of that, you will get 124x. Now, same number, plug in x equals 50. The marginal cost at x equals 50 is 124 times 50, which is approximately or exactly 6,200. So once 50 units have been made, the approximate cost of the 51st unit, the marginal cost is going to be $6,200. Now let's do the marginal revenue. Marginal revenue, that's just going to be our prime of x, and we're going to plug in the 50 there. Where is my revenue function? Here it is. Take the derivative of that guy, please. That will give us 3x squared minus 24x plus 40, right? And then if you plug in 50 right in there, you get 3 times 50 squared minus 24 times 50 plus 40. If you evaluate that, you will get $63,340. $6,340. So once 50 units have been sold, the approximate revenue from the 51st unit, the marginal revenue is $6,340. So let's do the very last one. What about the marginal cost? Marginal profit. Marginal profit. So find P prime of x. We can just subtract, but let's find the derivative of our profit function that we wrote on part A. That's going to be 3x squared minus 74 times 248x plus 40. Then this minus number just goes to 0. Now plug in x equals what number? 50. P prime of 50 is going to be 3 times 50 squared minus 148 times 50 plus 40. And if you do that, what will you get? You will get $140. So what does that mean? Once 50 units have been produced and sold, the approximate profit from the sale of the 51st unit, the marginal profit, is going to be $140. So that's how we can use the derivative to find the marginal cost, marginal revenue, and marginal profit. Now, I didn't know if that was going to be enough. But if you feel like, oh, I think I got this, you can stop the video and probably try the homework by yourself. And you can always come back, because the other two, I just made an extra page just thinking, what if you need an extra example when you're stuck on So I'll go ahead and go over example 5 and 6. I'll continue to do that. But if you feel like you got this marginal cost, marginal revenue, and marginal profit, go and try the 8 problems on the homework for me. But I'm going to continue this. Okay, I'm going to continue the other 2 that I grabbed from your homework. The demand D for a new rollerball pen is given by D equals This is the function. That's the demand function that we got. Where P is the price in dollars. It's a cubic function. First thing that we were asked to find is the rate of change of quantity with respect to price. So they want you to find the rate of change of quantity. Is that a good wording? It's the rate of change in demand with respect to price. But all right, we'll find it. We know how to simply find dt, dd, dp. We just take the derivative of the d function, which is written in p. So what's that going to be? dd dp equals, take the derivative of this one. Let's do 0.006 times 3. The coefficient is 0.018 p squared minus 0.6 times 2. That's going to be 1.2p. And then plus 180. So no more p. So we got the derivative function, and this will be used when we are asked to find the rate of change or things like that. So we'll keep it here. All right, B, how many units will consumers want to buy? What's going to be the number of demand, when the price is $25 per unit? Are they asking you for the rate of change or anything like that here? Not really, right? How many units will consumer want to buy? How many will they want? What's going to be the demand? So in this one, we're just simply finding the d value. So plug it into the original function. I remember on our first exam, a lot of you were plugging in the x value into the derivative function instead of the original function. But you just have to read it carefully to see where to plug in our number. Alrighty, let me write this down. Okay. I'm going to type this in my calculator, okay? You do the same thing. And let me know. You will have to let me know if you're not getting the same number. 0.006 times 25 cubed minus 0.6 times 25. Oh, that's getting squared. And then lastly, 180 times 25. When I evaluated that, I got a wrong number because I forgot to put a decimal there. Okay. I got 4,218.75. So that will be the demand if the price is $25 per unit. Now that one, I found it without using the derivative function. But let's read C. Because C, they want you to find the rate of change, huh? If they want you to find the rate of change at P equals 25, then that's the one where you want to plug in the 25 into the derivative function. So let's do that this time. 0.018 times 25 cubed, not cubed, squared. I need to remember that I'm using that one. Minus 1.2 times 25 plus 180. Let's get the number, and I kind of wrote the sentence down there for you as a fill in the blank to interpret this result. Excuse me. 0.018 times 25 squared minus 1.2 times 25 plus 180. I got 161.25. So let's interpret this number. The number of consumers who want to buy will, now this is a positive number, so we'll say this will increase by that number, 161.25, when the price is how much? $25 per unit, because that was the X value that we plugged in to find this rate of change. Now, the last questions kind of just asking you, would you expect this DP to be positive or negative? Now, recall that the quantity consumers demand is inversely proportional to the price. So we expect this to be negative, okay? As the quantity consumers demand is inversely proportional to the price. What does that mean? If it's too expensive, nobody's gonna buy it. Alrighty, that's example 5. Let me do the very last one. I'm very slow today for some reason. I think it's seasonal allergy, guys, but whenever you feel like you sneeze a little, like you cough a little, you get so scared. I'm like, oh my goodness, do I have this? I think I got allergy. All right, last one. Example 6. A particular computing company find that its weekly profit in dollars from the production and sale of X laptop computer is, so from making and selling X number of laptop, this is the profit they're making every week. So P of X is this long cubic function. Okay, so they are saying currently the company builds and sells 7 laptops weekly. Okay. So if they're making 7 laptops weekly, can we figure out the current weekly profit? Absolutely. Let's find P of 7. What's their profit for making 7 laptops? What is their weekly profit? Oh, I think I'm missing a decimal point. Negative 0.006 times 7 cubed minus 0.4 times 7 squared plus 700 times 7 minus 800. I want their number to come out to be a positive. I hope they're making a positive, like a profit. They're not losing money. So let's go ahead and type this in. Negative 0.006 times 7 cubed. Sorry, I was missing a decimal place there. So if you can please put it right after that first 0, that will be great. 0.4 times 7 squared. Plus 700 times 7 minus 800. I got it. They're making money. They're making a profit of $4,078.34. I just rounded it up to the nearest cents. I got 342. Okay, so that's their weekly profit. The next question is, how much profit would be lost? If production and sales drop to 6 laptops weekly. Okay, I can figure that out. We can figure that out by finding the profit at 6 laptops. So do the same thing, plug in 6 this time, and let's get their profit. And you know what we're going to do? We're going to just subtract these 2 answers. We're expecting this to go down, right? All right, let me go plug in 6 into this P of X, okay? I'm just going to copy the last line above on my calculator and change all the 7s to 6 this time. Guys, if I did that, when I did that, I got this number, $3,384.30. So, how much profit would be lost if they make 1 less laptop? Well, simply find P of 7 minus, oh no. How is that happening? If I just disappear, I am sure you'll be able to finish this one. Subtract those 2 numbers that we just got, 78.34. It's so funny because I got my iPad plugged into a charger right now. It's still losing battery. What's going on? All right, I subtracted those 2 values. Just making sure that I'm typing in the right number. 4078.34 minus 3,384.30. When I did that, I got $694.04. So the profit would go down that much. How much profit would be lost? $694.04 will be lost if they go down to 6 laptops weekly. Alrighty, what is the marginal profit if X is 7? Notice they're asking you for the marginal profit. What do you have to find then? You have to find the derivative of the profit function. So let's do that. P prime of X is equal to negative 0.018x squared minus 0.8x plus 700. Okay? Plug in 7 in there. Negative 0.0187 squared minus 0.8 times 7 plus 700. I hope my iPad stay on until I finish that very last question. Alright, I am typing in 0.018 times 7 squared minus 0.8 times 7 plus 700. What did you get? I got $693.52. So that's going to be the marginal profit at X equals 7. So let's use this answer to answer part D. Use the answer from part A and C. So currently, the weekly profit for making and selling 7 laptops is $4,078.34. But we just found out that the marginal cost at X equals 7 is going to be $693.52. So, estimate the profit resulting from the production and sale of not 88 laptops. Get rid of that extra 8 for me. Not 88 laptops. 8 laptops weekly. So what we're going to do is add the current profit of making 7 laptops and then add that marginal profit of $693.52. And let's add it. What's that going to be? 4078.34 plus 693.52. The profit resulting from the production and sale of 8 laptops weekly is approximately $4,171.86. So hopefully the last 2 examples that I went over help you on the homework. But 3.6 is short. I don't know why I took so long to record lessons for this, but I'll be back with 3.7, which is even shorter. I do want to see your submission for the square root decimal approximation soon on Canvas, but I'll also get back to grading your exam 2 shortly, okay? All right,